Welcome back everybody to another video of DCLA Bro. Today we're going to be starting our Chemistry 14C series, and our first topic that we're going to talk about in this series is going to be bond line drawings or bond line structures. So it's important to know how to draw bond lines since they're going to be a very reoccurring theme and overall skill that you're going to have for organic chemistry. So to draw bond lines, there are a couple of rules that we have to follow, and I'll go through them right now. So rule number one that we have to follow is that carbon chains are drawn as zigzags. So what does this mean exactly? If we're given this bond line structure right here, could you be able to tell me how many carbons it has? So something we have to know about bond line structures is that for every peak in our bond line, there is one carbon. So in this structure, there will be 1, 2, 3, 4 carbons. And if we were to draw our condensed form, we can see that there will also be 4 carbons. And if we were to draw the hydrogens, they would look something like this. So we can see that for bond line, the carbons that we have are drawn in a zigzag pattern, representing the amount of carbons that we have. So let's look at another example. Say we are told to draw the bond line structure for this condensed form molecule. What would the bond line look like? Something that we have to remember when drawing bond line structures is that our hydrogens are assumed. That means that we do not have to draw our hydrogens in our bond line structures for carbons. So to draw this bond line structure, we can first start off by counting the number of carbons that we have. We can see in our structure we have 1, 2, 3, 4, and 5 carbons. So that would mean that our bond line structure would be a zigzag pattern or a zigzag structure of 5 carbons. So if we were to start drawing, we can see that this structure right here would be our bond line, since we have 1, 2, 3, 4, and 5 carbons. Let's now look at another example. Let's say we're given this structure right here, and we were told to draw the bond line structure for it. So how would we draw that? We could add the hydrogens to this condensed structure just for better understanding. And so how will we approach this problem? We can use the same technique that we used in our previous problem by counting the number of carbons in our longest carbon chain. So let's start in the left side. We can have carbon number 1 right here, or carbon number 2, carbon number 1 as well in the bottom, since both of these carbons are equivalent since they're both attached to this one carbon. So for the sake of this problem, let's just say carbon number 1 is the one on the top. Carbon number 2 would be right here, carbon number 3 right here, 4, and same thing would be for number 5, since this could be carbon 5 or this could be carbon 5, and it does not matter which one you pick since they're both equivalent, but for the sake of this one, we're going to do carbon number 5 at the top. So now that we know that our carbon zigzag chain is 5 carbons long, we can draw that. So our carbon bond line structure will look something like that. Also, make sure you note that you can also draw it in the other direction, like this. It really does not matter which direction you draw it, as long as we have 5 carbons in our chain. But now you might be asking yourself, what about this carbon right here and this carbon right here? Shouldn't we add those? And yes, we should. But the problem might be where. And we cannot add them right here, or right here, or right here, or right here, since that is not correct. We have to make sure that we add our carbons to the correct carbon that they are attached to. So we can see that for this carbon right here, it was attached to carbon number 2. And for the carbon on the right side, it was attached to carbon number 4. So we have to make sure that when we add them to our bond line structure, they're attached to the correct carbon. So when we find carbon number 2 in our bond line structure, it'll be right here and right here. We can add our carbon to that and to this one as well. And for carbon number 5 in the bottom, it's attached to carbon number 4. So we'll find carbon number 4 right here and right here. And we'll add that substituent or attachment to it. And this will be our bond line structure for this molecule. Make sure that when you do draw the bond line structures in the end, you do not keep the carbons like I did for this problem, as they are assumed, and they do not have to be drawn in the final bond line structure. They're just for your tracking, and make sure that you have the correct number of carbons. So the correct bond line structure will look something like this, or like this as well. Again, it does not matter which way you draw it, as long as you have the correct number of carbons attached to the correct number of substituents. And that will be it for rule number 1. So let's talk about rule number 2 now. Rule number 2 states that all heteroatoms or hydrogens attached to heteroatoms must be drawn. So what does this mean? And first of all, what are heteroatoms? Heteroatoms can be any atom that is not a carbon. So for example, it can be a nitrogen, an oxygen, sulfur. Any atom that in this case is not a carbon, since we know that carbons and hydrogens attached to carbons are assumed. So let's look at an example to better understand this. Let's say we're told to draw the bond line structure of this molecule. And we can add our hydrogens as well. So how will we draw the bond line for this? We can use the same steps that we've learned before, like numbering our carbons in the Lawrence carbon chain. So we know that this will be carbon number 1, carbon number 2, and carbon number 3. But something that we have to notice is that the rule states that all heteroatoms must be drawn, and all hydrogens attached to heteroatoms must be drawn. So we can notice that between carbon 1 and carbon 2, we have an oxygen. And just after carbon 3, we have an oxygen attached to a hydrogen. So those must be drawn in their structure and are not assumed. So let's begin by drawing our bond line drawing. We know that this will be carbon number 1 right here. And we know that between carbon 1 and carbon 2, there will be an oxygen. So there will be an oxygen right here. And this would not be carbon number 2 here, since that is now our oxygen. And if you want, this will be 2 right here. But we don't count that, since we're only counting carbons. And following that, this will be carbon number 2 right here. And this will be carbon number 3 right here. And notice as well that after carbon number 3, we have an oxygen attached to a hydrogen. So we will have to draw that as well. And we will draw that like this. So we can see now that we converted our condensed structure to our bond line structure by following this rule, which states that we must add our heteroatoms, such as our oxygen, and hydrogen is attached to heteroatoms, such as the OH right here. Let's look at one more example. And again, remember that our bond line structure does not include the carbons. So the final structure will look like this. Okay, let's look at another example. Let's say we're told to draw the bond line drawing for this molecule right here. How would we draw the bond line for it? Okay, again, we can start by counting our carbons. So we know this is 1, 2, 3, and 4. And we can see again that between carbon 1 and carbon 2, we will have an oxygen, similar to this example. So let's begin drawing our bond line. And another thing we can notice is that we can just continue drawing our carbons since there's no other heteroatom in our carbon chain. So this will be carbon 1, or oxygen right here, carbon 2, carbon 3, and carbon 4. And now, similar to our past example that we talked about, our substituents, we can see that at carbon 3 we have an oxygen, and that oxygen must be drawn, since all heteroatoms must be drawn. So, at carbon number 3, right here, we must draw our oxygen, which will look something like this. And that will be our bond line structure for that molecule. Let's talk now about our third rule, which states that double bonds must be drawn as far away from each other as possible. So, what does this mean? Let's say that we're told to draw the bond line structure for this molecule right here. And I'm not going to draw the hydrogens since we're just going to assume that they're there. And, well, how will we draw the bond line structure for this? So we can first start off, like we always do, by counting the number of carbons in our longest carbon chain. And we can see we have 1, 2, 3, and 4 carbons. So we can just start off by drawing our 4 carbon zigzag. Like this. So how do you draw in the double bond substituents at carbon 2 and carbon 3? Would we just draw them like this and like this, and we won't, since we have to follow the rule that states that double bonds must be drawn as far away from each other as possible. So these two double bonds are close to each other since they're right next to each other from the same bond. So they have to be as far away from each other as possible. So the correct way to draw this will be like this. And you can just simply remember that when you draw a double bond, they always have to be facing this way in the peak. They are never really drawn facing this way. So that's one of the things that you can remember when drawing double bonds. And let's look at another example. Let's say we're told to draw the bond line structure for this molecule right here. And again, we can just assume that the hydrogens are there. What would the bond line look for this? So again, we can start by counting our carbons, and we can see that we have 4 carbons again. So we can draw the same bond line structure as we did before. But notice that, again, that between carbon 1 and carbon 2, we have a double bond. So between carbon 1 and carbon 2, we must have a double bond. And same thing for the double bond between carbon 3 and carbon 4. Carbon 3 and carbon 4, there must be a double bond. Like that. And that is how we draw double bonds in bond line drawings or bond line structures. So one of the things that I want to mention before we go to the next rule is that make sure you do not go over the octet when you draw bond line structures. So what do I mean? Let's say, for example, let's zoom in here. Let's say you have this bond line structure right here. And you are told that you were asked whether this carbon right here exceeds the octet or not. So we can see that this carbon has 1 bond, 2 bonds, and 3 bonds right here attached to it. And you might be asking yourself, well, this carbon only has 3 bonds, so it's under its octet. But no, because we know that there is a hydrogen that is not shown that is assumed. So in reality, this carbon has 4 bonds. So it's not exceeding its octet or below it. So for our final rule, it states that triple bonds must be drawn in a line rather than a zigzag. So what does this mean? So when we're given triple bonds and bond line, they'll look something like this. And you might be tempted to ask, well, how many carbons does it have? And you might say, well, from what we learned, it might seem that it only has 2 carbons. And this would be incorrect in bond line, since in bond line there is a carbon right here as well, and a carbon right here. Since if we were to draw this in a condensed form, we will see something like this. So this means that this structure would have 4 carbons. So that's what we mean when we say that triple bonds must be drawn in a line rather than a zigzag. So let's look at an example to better understand this. Let's say we're told to draw the bond line of this structure right here. So how would the bond line look? We can again start by counting our carbons. And we can see we have 6 carbons. You might be tempted to say that our bond line looks something like this. Since we have 6 carbons. and between carbon 3 and carbon 4. Carbon 3 and carbon 4, we will have a triple bond. But this is incorrect, since we've learned here that there will be a carbon also right here and right here. So this will be 4 carbons. In reality, this structure would have 8 carbons, which is not correct, since we saw that our structure has 6 carbons. So what is the correct way to draw triple bonds in bond line? We have to understand that, as we saw here, 4 carbons. So we have to make sure that we start noticing that the carbon before our triple bond must be the starting point of our bond line. So if we start drawing our bond line, we can start drawing it like this. We can see that a carbon 2 right here, we're going to have this structure right here implemented into our bond line. So it will look something like this. And this would be our bond line, since there is 1 carbon right here, another carbon right here, another carbon right here, another carbon right here, another carbon right here, which is a little bit hard to see since they're very close, and a final carbon right here, giving us a total of 6 carbons, which we have in our condensed structure right here. So this would be the correct way of drawing the bond line for a triple bond. Show it one more time, like this. This would be the correct way of drawing triple bonds in a bond line structure. And that was the final rule of our bond line video. Hopefully this was helpful in some way. I hope to make more videos like this in the future, so if there's anything that you'd like for me to improve, to do more of, less of, please let me know, and I'll catch you guys in the next video.